Okay, let's look at lesson 81 for Saxon 54, and we are looking at angle measures here. We've looked at angles before as they related to triangles, and we've looked at angles in other lessons. This time we're going to actually talk about how can we measure an angle, okay? As always, if you want to pause this video, if you haven't done the warm-up already, please take time to do that and review your division facts, do some mental math just to keep your brain focused on how you can do the operations of addition, subtraction, multiplication, division, and then solve this problem right here, and then come back and we'll continue with the lesson. All right, let's talk a little bit about this problem here in particular. How long is segment AB? How long is segment BC? The segment AB is how much longer than segment BC? So you're just using your skills here to measure using a ruler, a measuring device. So first of all, you might want to figure out what each division is signifying. So you'll notice that this is 1 inch, there's 2, so if you're in the middle, this would be 1.5, and in the middle of that is going to be 1.25, this is 1.75, or you could say 1 1/2, 1 1/4, 1 3/4 for those tiny little marks between the 1 and the 2. So to go from A to B, that's a distance of 1 1/2 inches. To go from A to C, that's a total of, you went past 2 and then halfway to 3, so that's 2.5. So segment A to B has a length of 1.5, segment A to C has a length of 2.5, and the difference between those, how much longer is that's AC, so that means BC from here to here, from B to C, is going to be the difference between 2.5 and 1.5. You're going from 1.5 up to 2.5. That is a distance of 1 inch. Okay? So we found AB, we found actually AC, and then to find BC, you would subtract those two if you wanted to. 2.5 minus 1.5 gives us the 1. Okay? And it's an inch longer. Okay? All right, let's talk a little bit about our new concept. Remember, we're looking at measures of angles. It says here in 1 hour, the minute hand of a clock turns all the way around once. So in 1 hour, this minute hand is going to go all the way around the clock one time. That means it spins a full circle, and a full circle has a measurement of 360 degrees. Each degree, okay, it was established at some point that a degree is 1/360th of a full circle. So each degree is going to be 360 of those to go around a full circle. Okay? And it says the minute hand, it forms a changing angle with the hour hand. So at 3 o'clock, the angle formed is a right angle. So at 3 o'clock, the minute hand is right up at the 12, and the hour hand is at the 3. That is a 90-degree angle right there. Okay? That's 90 degrees. At 6 o'clock, the minute hand is pointing at the 12, and the hour hand is pointing at the 6. So from one side of this to the other side, you do a full 180 degrees. Okay? So anytime you see a right angle, and we'll put a little box in the corner to show it's a right angle, that's 90 degrees. Anytime you see a straight line, and let's say we put a little dot there, to go from one side of the line and spin all the way to the other side of the line, that is 180 degrees. All right? Here's some other angles. If this is 90 degrees, to go from one side of the angle to the other side, it's like a corner, then half of that, okay, imagine if this was the corner right here. If this is the corner, if I take half of that, half of 90 is 45. So this angle right here is going to be 45 degrees. Okay? Remember, we can kind of relate all of this to 90. Here, if I go straight up and down, if I put a box right here, a corner, the box in the corner, that's 90 degrees. But then if I add on that much, which is half of this 90 over here, then I'm adding on another 45. So to go from this side of the angle all the way to that side, I went through 90 degrees, and then I added another half of 90. So 90 and 45 is the 135 that they're showing you there. And anytime you go from one side of the line all the way to the other side of the line, if you sweep through that angle like that, that is 180 degrees, okay, to go all the way from one side to the other side. All right. If you take a piece of paper, you fold it in half, as long as it's a nice straight piece of paper, you formed a 90-degree angle right there, okay? If you fold it again, meaning this corner is going to come down to that corner right there, and you're going to line it up, now you just cut that 90-degree angle. Basically what you're going to do is you're going to fold it right in half here. You're going to bring this edge and match it up with this edge down there. Now you just divided that 90-degree corner into two, and you made a 45-degree angle, okay? So if you unfold that now, you'll notice that you have creases or folds on your piece of paper. And you can see that this 180-degree angle is now divided into 45s. 45, 45, 45, and 45, because it takes 4 45s to give you 180. It'll take 2 45s to give you 90. So you can kind of see some of the relationships that are there, okay? If you have 3 45s, remember each one of these are 45, okay? So 45, this much would be 90. If you go from this all the way to 3 45s, 3 times 45 is 135, and 4 times 45 gives you the 180, okay? So all you're going to do here is, let's just kind of estimate. It says, using the paper you folded in lesson, estimate the measure of each angle in A through D. So it says, first find an angle on the paper that is close, and then if it's a little bit bigger, maybe we just go a little bit more than what we think it is, or what the angles that we know, or if it's a little bit less, we just subtract a little bit, okay? So we're just going to estimate. So again, I'm going to draw a 90, and I'm going to try and estimate half of that like that. So it looks like the angle that we're looking at is more than 45, but it's less than 90. So how much? Well, you're just going to estimate. It doesn't look like it's quite closer to 90 than it is to 45. So maybe I say it's 60. Okay? Here, if I draw straight up and down, this is 90. It doesn't look like my angle is quite 90, but it's close, so maybe I say it's 85. It's a little bit less. It's not quite 90. Okay? This angle, from one side of the angle to the other side, doesn't matter which direction we spin, but we always go from one side to the other side, from one side to the other side. This here, if I draw straight up and down, there's 90. It's more than 90. That much is 90. It's more than 90. Maybe it is, well, maybe it might be, well, that looks like that's about half right there. So it doesn't look like it's exactly 135. So maybe this much here is not 45. Maybe it's only 30. So maybe this is 120. This would be 135. Okay, you're just estimating. And then again, here's my vertical line. That would be 90. and it looks like it's right about in the middle maybe. I might guess that's right about 45. Okay? At 9 o'clock, the hands of a clock form an angle of how many degrees? At 9 o'clock, so let's think about this. If you've got your 12, your 3, your 6, and your 9, at 9 o'clock, you've got a 90-degree angle. Okay? At 3 o'clock, you would also have a 90-degree angle, just be on the other side. All right? Okay, so stop here. That's the new lesson, just looking at simple angle measurements. And now you want to dive into the mixed practice, wrestle through them, keep plugging through them, go back and check your work, and then if you need extra help or you have questions, come back here and I'll address some of them maybe, or we can talk about them if you have any other questions. All right, let's work through some of the mixed practice here and talk about these problem sets. Cecilia skated 27 times around the rink, forward, and 33 times around the rink backwards. In all, how many times did she skate around the rink? Well, so it looks like it doesn't matter if she's going forward or backwards. She's still skating around the rink. I would say that she went 27 times around the rink forward, and then she skated another 33 times around the rink. It just happens she went backwards. But how many times did she skate around the rink? It doesn't matter if she's going forward or backwards. She's still skating around the rink 27 times plus 33 times, so you just add those two together. Nectarines cost 68 cents per pound. Each pound, that means 68 cents for 1 pound. What is the price for 3 pounds? So 1 pound is 68 cents. If you had 2 pounds, it would be twice that. 3 pounds would be 3 times that. So you want to take 68 cents times 3 and figure that out. In bowling, you're going to take Amber's score and Beth's score, and it says was equal to Consuela's score. If Consuela's score was 113 and Beth's score was 55, what was Amber's? So I'm just going to use a little bit of a kind of some letters and an equation here. It says Amber's score right here and Beth's score together is going to equal Consuela's score. So Amber, I'm going to use an A, plus Beth's score, I'm going to use a B for Beth. Together, if I add them together, I will get, or it'll equal, Consuela's score, C. So A plus B equals C. I don't know all of these letters, but they give me Consuela's score, so this number is 113. Beth's score is 55, so the B, really, I could put 55 there. And then the A for Amber, we don't know that, so I'm just going to leave it as A. So remember, every equation is asking you a question. What, that's A, plus 55 will equal 113. Well, another way to do that is you take 113 and subtract 55, that will give you that A value. Okay, 84 students are assigned to each room. Oh, sorry, you have 84 students total. A third are assigned to each room. So you've got 3 rooms, room 1, room 2, room 3. 84 students, and you want a third of them to go into each of these rooms. So you want to divide the 84 students equally into 3 rooms, meaning you're going to divide them into thirds or divide them by 3. So you're going to take 84 and divide by 3. 84 divide by 3. Or the same thing, 84 times 1/3. All of those mean the same right there. Round 2,250 to the nearest 1,000. 1,000 means that value right there. So I look at the number right behind it. It's a 2, which is less than 5. So I round that off and replace it with zeros. So the nearest 1,000 is 2,000. You wouldn't go all the way up to 3,000 because 2,250 is between 2,000 and 3,000, but it's closer to 2,000 than it is to 3,000. Okay, in the word Arizona, what fraction of the letters are not A's? So let's count out how many total letters first. 1, 2, 3, 4, 5, 6, 7. So it's going to be out of 7. How many are not A's? R-I-Z-O-N. That's a total of 5. So 5/7 of the letters are not A's. That means 2/7 are A's. 2 out of 7 are A's. 5 out of 7 are not A's. Okay, the African elephant weighed 7 tons. How many pounds is that? Well, first of all, you need to know that 2,000 pounds is equal to 1 ton. So if that's the number of pounds for 1 ton, you've got 7 of them. So you're going to have 7 tons, 2,000 pounds, 7 times. 2,000 and another 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 2,000. 7 times. Or in other words, you take 7 times 2,000 and you will get how many pounds you have in 7 tons. Okay, you have a shoelace here. How many millimeters is that? Well, we're just using, the tip of the shoelace, just this part right here. Just using our measurement skills. So this is your 0, and you're going to kind of estimate. It looks like it comes right up to about there, which is halfway in between 10 and 20, which means that it would be 15 millimeters right there. Choose a more reasonable measure. So a box of cereal, 400 grams or 400 kilograms. Well, a kilogram, that's kind of, a kilogram is a lot heavier than a gram. So you want probably 400 grams. That would be a box of cereal. A pail of water, 10 milliliters is a small quantity. 10 liters is a little more reasonable. A liter would be like maybe a bottle of water, okay, a large bottle of water. If you've got 10 liters, that might be a pail of water. What is the date of the last Tuesday in February 2019? So in February 2019, what is the date of the last Tuesday? So we want to go Tuesday, and the last one is the 26th. 42,700 is how much greater than 34,900? Okay, first of all, we have to be able to take the words and translate them to numbers. So 42,700 is how much bigger, so this is the bigger number, 42,700 is the bigger number than 34,900. How much bigger is it? To find the difference, you're going to subtract these two numbers. So find out how far apart they are from each other. Subtract them and find the difference. Now, what I might do is I might figure out how much more do I need to add to 34,900 to get up to 42,700. If I add 100, that gets me up to from 34,900 up to 35,000. Let's do it this way. 42,700, 34,900. If I add just 100, that will get me up to 35,000. Now I want to get from 35,000 up to 42,000. So to get up to 42,000, from 35 to 42, from 35 to 40, that's 5, and then another 2 to get to 42, so that is a total of 7,000. And then to get from 42,000 up to 42,700, I just add another 700. So I added 100, a 7,000, and a 700 for a total of 7,800 is what I added to go from 34,900 up to 42,700. So if I was to subtract those, the difference between them is exactly that, 7,800. Okay, find the perimeter. Perimeter, remember, is the distance around. So if you were to walk around this rectangle here, you would go 10 units, then 5, then another 10, and another 5. You would add up those 4 numbers. The area is how many squares fill up the space. And your squares are 1 unit by 1 unit, whatever the units are. So I have 10 in each row, and I have 5 rows. So the area is going to be 5 times 10, or 50 squares. And we say units squared, or square units. Samantha was riding north when she turned 90 degrees to the left. Then, after turning, in what direction was Samantha riding? So if she's going north, we're going to represent that by drawing straight up on the piece of paper. Then she stops. She's going to turn 90 degrees to the left. So 90 degrees to the left, this is your left side, this is your right side. So she's going to be looking in that direction, and then she turns 90 degrees. Now she's going to be looking in that direction, and that means what direction is she going to be riding now? Well, she's going to be going, if this is north, this is south, this would be east. Now she is traveling west. Okay? All right, I'm going to leave these, all of these, to you to do all of these computations. Oh, there's an easy one. 3 times 7 times 0. Anytime you multiply by 0, that's 0. Ah, I just did that one for you. There you go. All right. And do all of these computations. Take your time. Double check. Remember that you always do exponents here before anything else. So make sure you do the exponents before you divide. Here, this equation is asking you a question. What times 7 equals 105? All right. Do all of these problems here. Don't skip any. Do them all. Double check your work. Work carefully, meticulously, and make sure that you're putting the time in that you need to in order to do well on this. Okay? All right. And we'll talk if you have any questions.